Alright guys, today we're looking at factoring trinomials in the form of x squared plus bx plus c. Trinomials, guys, tri means 3, so I'm looking at polynomials that have 3 terms, so 1, 2, 3. Every single one of these has 3 terms, okay, every single example. So these are called trinomials. Trinomials that are in the form of x squared plus bx plus c, they don't have a number or a coefficient out in front. The only coefficient there is a 1, and this makes it very easy to factor these expressions. If you remember factoring by grouping, every single one of our factored answers was the product of 2 binomials, meaning one group times another, right? So that's exactly how our answer should look here as well. What we need to do is know that for each of our first terms, since it's only 1x squared, or in this case 1n squared, the factors of n squared are going to be n times n, and those factors are always going to be in the first space of each binomial or each group. Now what I need to do is look at the factors of my c term, my constant term, which in this case is negative 16. What I'm going to do is I'm going to list all of my factors out. Remember, it's negative 16, so we have more factors than normal. Okay, so I'm actually going to move this up so I have a little more room. Positive 2, negative 8. All of these pairs multiply to be negative 16, our c term. What we need to do is figure out which of these pairs add up to be positive 6. Which is our middle term, or our b term. And if I look at all of these pairs and I add them up, this is 15, this is negative 15, negative 2 plus 8 is going to be positive 6. So I know that this pair multiplies to be negative 16 and adds to be positive 6. So these are the two numbers that I'm going to place into my binomials. So I'm going to have n minus 2 and n plus 8. Realistically, you could have also written this as plus 8 and minus 2. That order doesn't really matter because we don't have a coefficient out in front of our trinomial. But what we have here is now our factored form of this trinomial. And the way you check, again, is to just make sure that if you were to FOIL, you would end up right where you started. And we can show that n times n is n squared. N times 8 is 8n, so positive 8n. Negative 2 times n is negative 2n. And then negative 2 times 8 is negative 16. These middle pieces would combine, and I would have n squared plus 6n minus 16, which is right where I started. So I know that this is the correct answer. N minus 2 and n plus 8 would be the binomials that multiply to give me my original expression. All right, let's look at another example. In example 2, I have k squared minus 4k plus 3. Again, my answer has to be in this form, 2 binomials. Binomial means 2 pieces. K squared minus 4k plus 3. My front term, k squared, has a 1 in front of it. I know that k squared will always be broken down as k times k. Now what I'm looking at is the factors of my c term, which is 3. C is the constant term. Thankfully, 3 only has 1 pair of factors that work. If I add these up, though, this gets me positive 3. If I add these together, I get positive 4. 1 plus 3 is positive 4. What I need is actually negative 4 because my b term has a negative symbol in front of it. To get the negative 4, what I need to do is take the negative factors. Negative 1 times negative 3 would still get me positive 3. But when I add them together, negative 1 plus negative 3, I get negative 4, which is what I need. So these are going to be the numbers that I use, negative 1 and negative 3. This is going to be the correctly factored version of that trinomial. Again, you can always check by foiling. In example 3, 5x squared minus 20x minus 160. This problem looks a little intimidating because I have large numbers. If I look at all these numbers, though, I know that I can divide each and every one of those numbers by a GCF of 5. So I'm going to take 5 out of this. And what I'm left with is x squared minus 4x minus 32. Now all I have to do is break this up. I'm going to bring down the 5. And I know that when I factor x squared minus 4x minus 32, it's going to have to fit inside these two binomials. X squared is always broken up as x times x. And now I need the factors of negative 32. I need the factors of negative 32, so I have negative 1 and 32, 1 and negative 32, 2 and negative 16, negative 2 and positive 16, 4 and negative 8, negative 4 and positive 8. These are all of the factors or pairs that make up negative 32. I need to find the set of pairs that add up to be negative 4. Obviously, 32s aren't going to work because they're too large. The 16s won't work because they're too large. I'm down to two options. 4 minus 8 is negative 4, but negative 4 plus 8 is positive 4. So I know I want to use this pair instead of the one beneath it because I need the negative sign. So I'm going to have a positive 4 and a negative 8 to finish out my binomials. This is the completely factored version of this problem. In the last example, again, I have a number out in front, but if I look at the other two numbers, they're also divisible by 2, so 2 will be my GCF. When I take out 2, I'm left with x squared plus 16x plus 60. I know that when I'm done with this problem, my answer needs to fit inside two sets of binomials. What I'm looking at is the factors of positive 60 that add up to be positive 16. So factors of 60. This is where a calculator comes in handy. But the factors of 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. If I look at these factors, I notice that the only two pairs, or the only pair that adds up to be 16 is 6 and 10. So my factored polynomial is going to be x plus 6 and x plus 10, giving me an overall answer of 2 times x plus 6 times x plus 10. Alright guys, that was factoring trinomials of the form x squared plus bx plus c. Have a great day.